Good afternoon, everyone. My name is Tajinder Chahal. Thank you very much, EPTA and Nihalji, for giving this opportunity to discuss with you on artificial intelligence in pulp and paper industry. As we talk to each other on phones, there is artificial intelligence in that. We are in the process of driving the driverless cars. That is a part of artificial intelligence. So the paper industry is now way away from the artificial intelligence implementation. We are already using artificial intelligence in so many aspects which we do not even realize that we are using it on our day-to-day lives. So just an overview that in this presentation we will be covering some of the aspects of the artificial intelligence and machine learning in the pulp and paper processes, in the water treatment, as our pulp and paper industry is mainly 99% water and 1% of the fiber. So the implementation of various new technologies in pulp and paper will be starting from the implementation in water treatments. So once we implement this artificial intelligence or the machine learning in the system, it will give us a better overall maximum output of the equipments, will give us a better, smoother, and consistent product, and ultimately will reduce the cost of operations for the total paper making and the processes. So how AI is creating value in, across the globe. So it's a report from the McKinsey which shows that by 2025, we will be, the AI will be generating close to $3.5 trillion as a revenue from the different applications. And you will be surprised to know that almost 50% of the industries, they have already started using AI in a way, maybe from one application or another. And paper industry is no way away from that. Even in India, AI is implemented at a couple of sites. The customers are getting good ROI out of that. So we will be covering that how the paper industry can get more benefits out of that. So how does AI creates value? Definitely we are having automations in our system. So the linear automations, we are measuring the data, we are giving some feedbacks to the system, we are giving the target values, it may be 10 to 15% variations. The process is just getting the data from whatever the sensors we have already installed in the system. So we check the critical parameters from the system. That reading goes to our DCS or PLC, and the process is controlled with that. But with the AI implementation, there will be real-time tracking of all critical parameters. We will come in the next slides that how these parameters for the different application will help us to make a smoother process, and will making a total paper making cost will be reduced with that. The optimization of machine learning algorithms will definitely help us, because as the artificial intelligence, the next step is the machine learning. Suppose we have developed some algorithms already in the system. So how it's different from the linear integrations which is already available in the, our industries. So the current linear integrations will not learn from the process or not learn from the histories. Suppose some process is having some problem. So if it's repeating again and again, and unless someone will go and change the set points in the system, that problem will not be rectified by the DCS or PLC itself. Whether after implementation of AI or machine learning, so these algorithms will be learning from the history, from the curves. They will be regenerating the new algorithms so that we can get a smoother and a better outputs in the long term after implementation of AI. The predictive control is the heart of this technology. Suppose something is happening rapidly. So what is the function of AI or ML in that? So it will be predicting why this problem is happening. So it's like 5-wire approach, that why one consistency is changed. So maybe that is from the parameter of which is changed at the back end. Why that parameter is changed, there is change in the raw material. Why that raw material is changed, there is change in season or weather. Why that season is changed, because that raw material is bought from a place where that is maybe very hotter or very colder. So that the change in one parameter is related to a number of other parameters. So this a predictive control will help us over a time to get at the root cause of the problem. And once it learns from that root cause, in the future, whenever that change is happening, so this will be giving us a proactive control so that the system is not having any issues in the long term because of the same parameters changing in the system. So why AI in pulp and paper industry? Definitely, as I was telling, that paper industry is no way away from the pulp and paper, from AI implementation. We already have so many sensors in the system. It may be the pH sensors, the consistency sensor, the temperature sensors, the vacuum sensors, the paper machine speed analyzers, the whole number of hole counters. So, but these all sensors, we are generating a lot of data, but we don't have, sufficient manpower or time to analyze all these data and get maximum output of that. So AI implementation will definitely help in that, because it will be giving us a real-time monitoring of all the parameters which are available in our system, analyzing at a single platform, which will be a cloud-based platform, analyzing real-time and giving output real-time to the machines so that we can get a better, smoother, and a consistent process output. So again, as what I was telling, in the linear integration, because we always say we already have automation, but there is no decision-making by the process itself in the system with the linear integration or the conventional DCS or PLCs. With implementation of AI, it will be taking decisions. As we can take the example, implementing the AI is just like taking birth of a child at home. Once the child takes birth, he learns for a couple of years from the family, then he start learning from that, and eventually he start taking decisions out of that. Similarly, once we install our sensors or our technology at the system, for the first couple of days, it will be a learning curve. It will be learning how the system is behaving with the different changes happening in the system, not only with the process parameter which we are monitoring, but how that process parameter is related to the n number of other parameters in the system. So after making the algorithms and completing the learning curve, it will be making decisions by itself, which will be cutting down a lot of human intervention in that. It will also reduce the dependency of manual controls. Definitely, if it's an automated control, it will be having a huge impact over the manual controls. Suppose it's observed at many different sites, according to the skills of the manpower, one shift is running very well, another may be having some problems rapidly, and the third may be having some different problems. But if the decision making is through a standard algorithm, and that algorithm is continuously learning from the curve, so it will be having a smoother operation, smoother decision makings throughout the shift, throughout the week, throughout the year, or even the long terms. So what we call is this platform is like Elixir. So Elixir is our, the trade name for the product. It's a real-time monitoring system. What it do is, you already have sensors installed in the system. We install some additional sensors in the system so that we can have a complete control of your process. So I'll come to, in the next slides, come to the different application-wise. And from these sensors, on the real-time monitoring, we will be deriving the data inside. The data is sent to the cloud real-time and is analyzed real-time, and will be giving back the feedbacks to the system. And the data visualization will be there. Because in the traditional systems, only the couple of mills will be having the data visualization available in hand with everyone. With this platform, being a cloud-based platform, anyone who's having the username access for that can access the data anywhere, can see what's happening in the system, and also the system, as the data visualization is there, so multiple observations can be done on that, and a smoother output can be achieved. So this is automated intervention, as I already told you. So as we reduce the human intervention in that, the chances of variation in the process is reduced. So with the real-time continuous data monitoring, so there's, I can take an example, suppose checking a consistency. It will take like 3 to 4 hours, right from drawing the sample from the site, taking the sample to the lab, then putting it in the oven, then calculating it, sending back to the process. So if it's a real-time monitoring for that, on the basis of that, some decisions can be made so that this sample can be drawn robotically, real time. So means as we see if a mill is having, say, 1 testing a day and another mill is having 8 testings in a day. So the mill which is having 8 testing a day will be having a better control over the system. What if we increase this testing frequency by every 5 minutes? If with 8 testings a day, we are getting a good control, and with having the 12 testing every hour, so it will be a much more controller system. So AI will help in that and will give definitely a better, smoother product and reduce in the cost optimization of this. Another thing is as machine learning is very much required for the future, because as we were discussing that the industry is expanding. So the availability of the subject matter result experts is limited. So they can't be available at the different sites. So if machine learning is there, so based on that, there will be smoother process at even the remote locations at the prime locations. Along with that automation, which you already have, that can give you a better, more output in the terms of economics and in the productions. It will be resulting in optimal plant operations. So as I was telling that from the applications, I will be discussing 2 or 3 applications quickly. First is microbial control. So now as everyone is talking about the ZLD, so definitely when we will be recycling the water in the system, so the microbial control activity will be increasing, because once the water is going to the effluent treatment plant, we are generating, or we are producing bacteria in that to run the effluent treatment plant. Then we are taking that water back to the system. So we are generating the bacteria. Definitely that bacteria will be there once the water come back to the system. So we need to have a closed loop control, so that how much bacteria need to be generated and how much need to be killed once it's come back to the system. Because if we add too much of the biocides, it will also again going back to the ETP and will be disturbing the effluent treatment process. So then the ZLD will become even a difficult challenge. So what can be done with the implementation of AI is in the traditional total bacteria count or fungus count, it will take close to 2 to 5 days, depending upon the testing procedure which we are using. So means we take a sample, we test it, after 5 days we get a report, like SRB is close to 5 days. So then we take a decision. By the time if the machine is producing 300 tons, we have already produced close to 1,500 tons. And then we take a decision, again wait for the next one, again 1,500 tons paper will be produced. By just making one changes and observing it, we have already produced a huge amount of paper on that. What we do with AI implementation is we will be checking the yes, okay. So we will be having the multiple data sources for that, not only the total bacteria counts with the other parameters affecting the bacterial activity like pH, temperature, consistency, ORPs, and that will give us an index which will help us to optimize the dosages of the products and giving us a better control. This is example from one of the implementations where the number of holes per day was an average close to 20 plus, and after implementation of this AI, this went down less than 5. Similarly, with the bacteria counts, as we were having the closed loop controls, so which was having 2 digits in 10 raised to the power 4 came down to single digit, less than 5. Again, second one is the retention aid. So in that also, in the traditional one, we are just checking the white water consistency, and based on that, we are making the decisions. But with AI, whatever the sensor you already have in the system, maybe the temperature, pH, conductivity, ORP, the vacuum levels, the machine speed, jet wire ratio, that can also be hooked up with the system, which will be making a more prescribed decisions for the retention aid system, giving us a consistent white water consistency and can say stable drainage and a smoother process. Water treatment, there are many applications where we have already implemented it as due to the real-time monitoring of all the parameters, right from reel to river to ETP and again back to the paper machine. If it's controlled from the source, not at the end of pipeline, so it will be having a different scenario in the mill. So this real-time measurement along with the automation will help the industry achieving the ZLD and reducing the water consumptions in that. Just coming to the conclusion, so because it's being a big subject, we can discuss for the whole days or a week on that. And but with this limited time, I'll just give you a brief. There are many other applications available. You can always contact us and we can discuss in detail according to the systems. With just this, I would like to conclude the session with this, by implementing AI and machine learning in the system. So based on the predictive control will help big way to improve the speed of precision and different stages of the process, reducing dependency on the manual controls. As we reduce the dependency on the manual controls, we have a better quality throughout the year. So we will be having a better economical conditions for the mills and will be saving a lot in the cost. So as the cost will be saved, so it will be good for the industry. The efficiency is improved, which is very much required for the system, and we can build a sustainable solution for the industry. So AI plot platform convert the unstructured content into an actionable intelligence. That's it. Thank you very much.